Hello everyone, I hope you found this worksheet to be more on the simpler side compared to all the conic section problems that we were doing. Of course, some of these problems can be quite challenging, so I'm going to go through each one, showing the work, again, emphasizing the difference between an exact value and an approximate value. So make sure you follow along, checking your solutions as well, and let me know if you have any questions. All right, so looking at number 1, our two legs are 6 and a missing side A. So we're going to have 6 squared plus a squared equals 10 squared. This gives us 36 plus a squared equals 100. Subtracting 36 from 100, we're going to get 64. Now, when this number comes out to be a perfect square, there's only an exact answer. So the square root of 64 is just 8. So this is both an exact answer because it's just a single whole number. There's no decimal approximation necessary for this one. So 8 equals 8 is the solution. Number 2, our two legs are numbered 6 and 4. So we have 6 squared plus 4 squared. Our hypotenuse is b, so that equals b squared. So we're going to get 36 plus 16 equals b squared. Adding 36 and 16, we get 52. And we had an example like this. So b is going to equal the square root of 52, but that's not in simplified form. This is actually 4 times 13. 4 is the largest perfect square. So the exact answer is going to turn out to be 2 radical 13. And then all you have to do is type in the square root of 52 on your calculator. So then b is approximately, rounding to the nearest hundredth, 7.21. All right, for number 3, our two legs are numbered as 4 and 2, so we could say 2 squared plus 4 squared equals the hypotenuse squared, which is c squared. So we're going to get 4 plus 16 equals c squared, so c squared is going to equal 20. C is equal to radical 20 that we know we can simplify into a 4 times 5. So the exact value is 2 radical 5. The approximation here is a 4.47. All right, and number 4, again, our two legs are numbered, so we have 3 squared plus 6 squared equals d squared. So we're going to get 9 plus 36 equals d squared. So d squared is going to equal 45. D is equal to radical 45. And to factor this, we're going to say it's 9 times 5. So the exact answer is 3 radical 5. Again, for the approximation, all you have to do is type in radical 45, and we actually get a 6.7. It's actually 6.708, so it's going to round to a 6.71. So make sure that you have a 1 there. You're not just leaving it as a 0 because there's an 8 after it. All right, now number 5, these markings here mean the two legs are congruent, so this other leg is also 3. So we could say 3 squared plus 3 squared equals e squared. So we're going to get 9 plus 9, which is 18, equals e squared. So e is going to equal the square root of 18, which we can factor into 9 times 2. So the exact value here is 3 radical 2. The approximation of the square root of 18, I'm going to write it over here, so e is approximately a 4.24. So again, this is the exact answer. This is the approximate. Similarly, in number 6, again, these markings here mean the two legs are congruent. So we're going to say 5 squared plus 5 squared equals f squared. So we're going to get 25 plus 25, so we get 50 equals f squared. So f is equal to the square root of 50, which is 25 times 2. So the exact simplified form is going to be 5 radical 2. And the approximate radical 50 turns out to be a 7.07. Now, what I want you to sort of notice here is, and it's going to lead us into our lesson of special right triangles, Notice each side here is 3, and the hypotenuse turned out to be 3 radical 2 in exact form. Notice in number 6, each side is 5, and the hypotenuse was 5 radical 2. So there's that connection there, and when we understand special relationships, we can go through the problems a lot quicker. That's the whole goal, to be able to do these problems as efficient as possible. So now that we're looking at number 7, the two legs are equal, again, by the markings here, but they're also a variable. So I'm going to write this as g squared plus g squared equals 6 squared. So I'm going to combine these two. There's just one g squared plus another g squared, so we can combine the like terms, and we get 2g squared is equal to 36, which makes g squared equal to 18 when we divide by 2. So g is equal, and again, we just did the square root of 18 back in number 5, so I can say first it's going to be 3 radical 2, which is then approximately a 4.24. All right, and then in number 8, very similar here, we could say h squared plus h squared equals 4 squared. So we get 2h squared is equal to 16. Divide both sides by 2, h squared is equal to 8, and then h is equal to the square root of 8, which factors into a 4 times 2. So the exact value here is going to be 2 radical 2, and then radical 8 is approximately a 2. It says 2.828, which means we're rounding it to a 2.83. Okay, so hopefully you guys were doing okay with the first page. All right, here, even though we're given a sketch, the sketch has just all variables labeled as the sides, and we're given the different information for each side. And if you notice, some of these measurements have radicals in them already. So j is equal to 3 radical 2, k is 3. So we're still looking for the hypotenuse in this case. So we're going to write this out as 3 squared. But this next quantity, I want to write it in parentheses as 3 radical 2 squared, and that's going to equal I squared. So I'm going to get 9. Remember, 3 radical 2 times 3 radical 2, we could write like this, which really becomes 3 times 3 is 9. And then radical 2 times radical 2 is radical 4, so it's just 2, so we get an 18. Or from previous examples like number 7 and 5, we notice that 3 radical 2 is what radical 18 is simplified, so here we're just squaring it and we get back to 18. So we get 9 plus 18 equals I squared. I squared is going to equal 27, so I is going to equal square root of 27, which is 9 times 3, so I is equal to 3 radical 3, and then that's approximately 5.20. Now notice here it's actually a 5.196, but that 6 is rounding that 9 into a 10, so we could really say that 6 is rounding that 19 into a 20. So it's a 5.20 as the approximate value. All right, for number 10, p is 4 and n is 2 radical 5. Again, these are the two legs, so we're going to say 4 squared plus, in parentheses, 2 radical 5 squared equals m squared. So we're going to get 16. Here we're just simply squaring the 2, which is 4, and then squaring the radical 5, which is just 5. Not 25, it's either the square root of 25 or just 5. So we get 4 times 5, which is 20. So then n squared equals 36. Now, since 36 is a perfect square, there is no two versions of this answer. N is just going to equal square root of 36, which is 6. So there's no need to approximate this. It's a nice whole number. All right, for number 11, we see r is 4 radical 2. Now the hypotenuse is s. So here we're going to write that r squared, actually the 4 radical 2, plus q squared is going to equal 4 radical 3 squared. So squaring 4 radical 2, we square the 4, which is 16. We square the radical 2, which is just 2. So 16 times 2 is going to give us 32 plus q squared. Over here again, I square the 4, which is 16, and then I square radical 3, which is just 3. So I get 16 times 3, so that's 48. Subtract 32 from both sides, so we're going to get a 16. Again, 16 is a perfect square, so q is going to equal 4. All right, for number 12, again, we're given our hypotenuse in one leg, so we're going to say v squared, so 3 radical 5 squared plus u squared equals t squared, so 5 radical 2 squared. 3 radical 5 squared just becomes 9 times 5, so we get a 45 plus u squared. 5 radical 2 squared will become a 25 times 2, so we get 50. So u squared subtracting 45 from 50 will give us 5. So u is just going to equal square root of 5, which is approximately 2.24. All right, now for the next two, our last two problems, there's no need to really write this out. It's just asking us to find the lengths of the sides. So the approximate form, we're just going to kind of skip over for these. But remember, the problems in the examples here is that we want to use a universal variable here. So even though x is given, I want to avoid using that. So in this case, I could pick a letter that's not here. I'm going to use a y. So we know that x is equal to square root of 39. I'm going to let p, if the ratio p to q is 2 to 3, I'm going to say that this is like 2y, and then q is really 3y. So we're going to have the two legs squared and add them together. So we're going to get 2y squared plus 3y squared is going to equal radical 39 squared. So I'm going to get a 4y squared plus a 9y squared equals just 39. Now I can add the two y squared terms together, get 13y squared equals 39. Divide both sides by 13, which will give us y squared is equal to 3. So y is equal to radical 3. So this means that p, which is equal to 2y, is really 2 radical 3. And then q, which is 3y, is really 3 radical 3. Now again, you can go back and check. But I tell you, when you square 2 radical 3, you're really going to get 4 times 3, which is 12 for p squared. And then when you square 3 radical 3, you're going to get 9 times 3, which is 27. So p squared is 12, q squared is 27. 12 and 27 will give you the 39, which is that x squared value. All right, likewise for 14, the ratio of r to s is 3 to 4. I'm going to use an x here because that's not one of the variables for the sides. So r we could say is 3x and s is 4x, and then y is 5 radical 2. So the way I'm going to write this is 4x squared plus 3x squared equals the quantity 5 radical 2 squared. So we're going to get a 16x squared plus a 9x squared. This will give us a 50, a 25 times 2. Adding 16 and 9 together will give us 25x squared is equal to 50. Divide both sides by 25, so x squared is going to equal 2, and then x equals radical 2. So this now tells me that r, which is equal to 3x, is 3 radical 2, and s, which is equal to 4x, is 4 radical 2. So when you do the check for this, 3 radical 2 squared will actually give us 18, 9 times 2, and then 4 radical 2 squared will give us 32. So 18 plus 32 will give us 5 radical 2 squared, which is 50. So just going through the check using the actual Pythagorean theorem there. All right, so these are all the solutions. Make sure that you have checked over these. Upcoming lessons, we'll be focusing on special right triangles next, and then reviewing some trig ratios, like I said, which is sine, cosine, and tangent. As always, have a good day, and let me know if you have any questions.